This training module covers the RDR 4000 IntuVue Weather Radar for the EJETS Load 27-2 and E2 aircraft. This presentation is Honeywell proprietary information, is subject to export restrictions, and is intended for personal use only. This material was developed by the Honeywell Flight Technical Services Organization. For more information and training, go to pilots.honeywell.com. The Embraer 27-2 and E2 aircraft can be equipped with the optional RDR 4000 3D automatic weather radar system, which is an airborne solid-state X-band weather radar system. The function of the RDR 4000, also marketed as IntuVue, is to increase situational awareness of weather by detecting and annunciating hazardous weather conditions such as heavy precipitation, turbulence, lightning, hail, and wind shear. The RDR 4000 has many new functions, including enhanced turbulence detection, forward-looking wind shear detection or predictive wind shear, and extended ground map analysis mode. The weather radar feature replaces some of the traditional manual radar controls such as tilt with an automatic operation and provides automatic reduction of ground clutter. The database enables a complete 3D picture of weather and terrain from the ground up to 60,000 feet and from the nose of the aircraft out to approximately 320 nautical miles. As with other radars, the system is more accurate the closer the storm cells are to the aircraft. This ensures that the most reflective part of the storm is detected. The RDR 4000 contains an internal worldwide terrain database that is a version of the Honeywell EGPWS database, but without airports, runways, and obstacles. This database also enables the RDR 4000 to extract ground clutter without the significant losses associated with signal-based ground clutter suppression techniques. Because the RDR 4000 uses only the terrain information and not airport and obstacle data, regularly scheduled updates are not required. The terrain database allows the system to distinguish between weather returns and ground returns. Therefore, only weather information is shown in the weather modes, and only ground returns are shown in the ground map mode. In ground map mode, the ground returns are provided by the radar returns and not the internal terrain database. This allows for an independent verification of position. In weather mode, the RDR 4000 detects precipitation reflectivity and sends the data to a 3D volumetric buffer that stores data in 3 dimensions. You can think of the volumetric buffer as a giant Rubik's Cube. Each square is at a certain position in range, azimuth, latitude, longitude, and altitude. In each of these squares, information is stored about reflectivity, turbulence, and if the returns are weather or ground-based. The automatic scanning stores all of the weather and ground return information in the 3D buffer from 0 to 60,000 feet in altitude and out to 320 nautical miles in front of the aircraft horizontally. As with other radars, the signal is the most accurate the closer the aircraft is to the weather. Weather data can be viewed on the map and HSI displays with primary and secondary returns based on flight plan path and aircraft altitude. Vertical profile views of the weather can be shown on the VSD along the aircraft track or a selected azimuth. Since there is no tilt control, pilots do not use the control panel to control the radar, but instead use it to request information from the 3D buffer. This information can be presented in many ways, including comparing the weather in the buffer to the aircraft's flight path or vertical flight plan. Modes will be covered later, but in this image you can see the primary and secondary returns on the lateral map as solid and crosshatched patterns. Note that weather is not separated into primary and secondary weather on the VSD. For scans above the freezing level, the system automatically increases the gain to make less reflective frozen storm tops more visible. Remember that there is no tilt control on this radar, so this function is automatic. The scanned information, which is stored in the volumetric buffer or memory, is continuously updated and compensated for aircraft movement. If left uncorrected, the effect of the Earth's curvature can be quite significant, and this error is apparent in other onboard weather radars. In the picture shown here, the aircraft is at flight level 250, but because of the Earth's curvature, the center of the beam is above 27,000 feet at 60 nautical miles, almost 37,000 feet at 120 nautical miles, and at 44,000 feet at 150 nautical miles. This effective curvature of the Earth is automatically compensated for in the RDR 4000. That means that the weather shown on the display at a particular altitude, like flight level 250, is the actual weather at that altitude. The weather controller is a soft control on each MFD and is similar in layout to the Primus weather radar controller. The weather controller is displayed by selecting the weather tab at the bottom of the MFD using the cursor control device. When the weather radio button is selected, the weather mode is displayed. In the weather mode, the system is fully operational and WX is displayed in the mode field. The weather mode provides weather, turbulence, and forward-looking wind shear detection. The system processes the data to fill the 3D buffer and extracts the selected data for display. Returns determined to be ground clutter are not shown. If weather is selected before the initial RTA warm-up period is over, standby or STBY is displayed in the mode field. In the standby mode, the transmitter and antenna scan are inhibited and the display memory is erased. When the warm-up is complete, the system automatically switches to the weather mode. The slave mode annunciator is displayed in amber when the on-side controller or control process has failed. The slave annunciator appears in the HSI on the on-side PFD or on the MFD weather window and shows the on-side is slave to the other side. Weather targets are color-coded by the intensity of the return. The display correlation to the approximate rainfall rate is shown in the table here. Black for very light return or none, green for light, yellow for medium, and red for strong. Note that the color magenta is used to show turbulence and does not indicate rainfall intensity. In the lateral view, the system analyzes data in the 3D volumetric buffer to show weather relevant to the aircraft's flight path in solid colors and show weather secondary to the aircraft's flight path in crosshatched colors or shading. In the vertical view, or VSD, the RDR 4000 displays weather along the flight planned route when a flight plan is active and the radar is in the auto mode. No distinction between primary and secondary weather is made on the VSD. All weather displayed on the VSD is displayed as primary weather. Selecting Ground Map on the Weather menu activates the Ground Map mode, which displays ground map data on the lateral map and on the HSI. When Ground Map is selected, the display of weather is suppressed on both the lateral and vertical displays. The purpose of the Ground Map mode is to aid in identifying prominent terrain features such as coastlines, lakes, and large built-up urban areas. This mode provides an extended ground map picture by piecing together individual scans and combining them in the buffer for display. Reflectivity data that is considered ground clutter and removed from the weather views is the basis for the ground map. Data from the terrain database is not used, providing an independent verification of aircraft position. Selecting STBY on the weather radar controller activates the standby mode. When the RDR 4000 is in standby mode, the system is still energized but is not transmitting. STBY is displayed in the weather mode annunciator window. Force standby mode is activated during landing if weather mode was selected. This prevents the radar from transmitting as the antenna is not driven on the ground. The RDR 4000 automatically takes itself out of force standby when the aircraft is no longer on the ground or the aircraft is aligned on the runway and RAS is installed. To override the force standby mode, both pilots must select the FSBY OVRD or force standby override checkbox on their respective weather radar controllers. This should only be done when the aircraft is away from the gate and ground personnel. Selecting VSD weather on the weather controller presents a profile view of the weather depicted by color intensity patterns above, below, and ahead of the aircraft in the direction of the flight plan, selected azimuth mode, or track if in heading mode. The selection is defaulted on, but can be turned off by the pilots by deselecting the checkbox. Selecting secondary weather on the radar mode controller displays secondary weather on the MFD or HSI. Secondary weather is weather that is outside of the FMS flight plan path. Secondary weather is defaulted to on when powered up, but can be decluttered from the display by deselecting the checkbox. Removing secondary weather is useful in decluttering the display. A good example is when you have a high or low stratus layer that fills the screen with secondary weather returns. When selected on, SECWX is displayed in the Weather Mode window. React is a submode of the Weather Detection mode and defaults to off. Selecting RCT puts the system in preset gain, and WX/R is displayed in the Weather Mode field. When React is enabled, magenta arcs are used to show areas where the radar return signal is attenuated because of intervening weather. The Rain Echo Attenuation Compensation Technique, or REACT, compensates for attenuation of the radar signal as it passes through rainfall. The magenta field indicates areas where further compensation is not possible. Any target detected in the magenta field is not calibrated and must be considered dangerous. If the attenuation is severe enough, weather behind a storm cell may not be detectable, or it may be displayed as being less severe than it actually is, for example, green instead of yellow. When hazard is selected, hazards such as hail and lightning are displayed. When the selected mode is WX/H, the radar overlays hazard icons where lightning or hail is detected, on top of the traditional reflectivity and turbulence. When hazard is selected, and in the event an area is determined to likely contain both a lightning and a hail hazard, only the hail icon is displayed, since it's considered a more severe hazard. When the ground map display mode is active, the hazard display mode and react display selections are ignored, and the hazard icons and react information are suppressed. When turbulence is selected, the turbulence detection mode is active. Turbulence is defaulted to on upon aircraft power-up. The turbulence mode is available at any range, but only displayed within 60 nautical miles of the aircraft. Weather returns are in green, yellow, and red, with turbulence shown in magenta. When the turbulence detection mode is selected, WX/T is displayed in the Weather Mode field and only affects the on-side controller. Note that React, Turbulence, and Hazard can all be turned on at the same time by checking all three boxes on the controller. In Auto, the RDR 4000 compares the active FMS flight plan waypoints and altitudes with the scanned weather. When Auto is checked and no flight plan is available, the RDR 4000 predicts the flight path and displays weather based on altitude and ground speed. This applies in level flight as well as climbs and descents. Auto is displayed in the weather mode on the MFD and PFD when selected. When altitude mode is selected, the pilot can select a specific altitude for weather display on the lateral map and HSI. This is referred to as manual altitude select mode. The altitude selector is shown as a horizontal line on the vertical display and a digital value in the MFD weather window and is controlled by the CCD knob. The initial altitude is set to the 1,000 foot increment nearest the current aircraft altitude. When an altitude is specified, only weather at that altitude is sent from the RDR 4000 to be shown in the lateral views, lateral map, and HSI. Altitude mode is an analysis mode. It is useful in several ways. It allows the pilot to evaluate the height of cells across the entire plan view display, allowing them to select a deviation path. Also, in areas of high stratus within the flight plan path envelope, they can select a layer below the aircraft by removing the clutter while still providing protection. When azimuth is selected, AZM is displayed in the weather window, and the crew can select a track using the CCD knob, along which a vertical weather slice is extracted for display on the VSD. This is referred to as VSD azimuth mode and should be used when trying to determine the vertical profile of a particular cell that is not in the aircraft's route of flight. A gray line is displayed in the lateral display corresponding to the selected azimuth and is controlled by the CCD knob. When transitioning from auto to manual gain, the controller initializes to 0 dB, so no transient is observed in weather reflectivity. The crew can adjust the gain between -16 and +10, or 0 to 100%, by using the CCD knob. The gain value is displayed in the weather window. The weather test mode is activated by selecting the WX prompt to on the MCDU test page. Pushing line select key 4 left toggles between off and on with the current selection in green large font. The test mode is activated on both sides, regardless of which MCDU made the selection. When the RDR 4000 is in test mode, the test pattern is displayed on the MFD and VSD if weather is selected for display on the map. The forward-looking Windshear oral messages are also heard during the test. Note that during the test the radar does transmit. However, it's a very short pulse and the safe distance is actually inside the aircraft's radome. The RDR 4000 measures areas of wind shear and presents the information for display on the HSI and the MFD by providing azimuth and range to the detected wind shear area. The forward-looking wind shear icon is a series of red and black bands in the area of the wind shear, followed by searchlights or yellow lines outside of black lines that extend from the far edge of the wind shear event. Multiple events are possible. If a predictive wind shear caution or warning event is encountered, it is automatically brought into the view on the lateral map or MFD. The wind shear icon is displayed in the lateral view or MFD with searchlights not to exceed 20 degrees either side of centerline. The HSI is automatically displayed in the 90-degree display mode or arc mode. When the RDR 4000 wind shear detection caution alert is received, the amber wind shear ahead annunciator is displayed on the ADI in a reverse video cutout. This annunciator does not flash. When the wind shear warning alert is received, the red wind shear ahead alert is displayed on the ADI. This annunciator flashes for the entire alert. When a warning is received, the orals wind shear ahead is heard for takeoff, and go around wind shear ahead is heard for landing and go around. Note that when a go around is executed due to this alert, the pilot will not have the reactive wind shear escape guidance unless a reactive wind shear alert is subsequently triggered. If both the forward-looking and reactive wind shear alerts are issued at the same time, a priority scheme is activated to prevent two alerts from being enunciated at the same time. The priority is as follows: reactive wind shear warning alert from the ground prox system, forward-looking warning alert from the RDR 4000, forward-looking caution alert from the RDR 4000, and then reactive wind shear caution alert from the ground prox. Note, if the RDR 4000 forward-looking wind shear is installed, the reactive wind shear caution alert from the ground prox system is suppressed. The FAA Advisory Circular AC 20-68B defines the method for determining the MPEL boundary. All personnel should remain beyond the distance indicated in the illustration shown here. The MPEL is the further of two distances: the near field far field boundary, which is the distance from the antenna that it takes for the beam to form. The second is the distance where the radiation level exceeds the U.S. government standard of 10 milliwatts per square centimeter. In E2, the MPEL distance is 11 feet or 3.4 meters. The safe refueling distance is 2.24 feet or 0.7 meters. In test mode, the system will transmit two 500 microsecond pulses at the beginning of the test sequence. The safe distance for test mode is 0.71 inches or 1.8 centimeters, which is still well inside the radome. For more information on Honeywell products and services, go to www.honeywell.com.